Yeah, I did one of them school. Yeah, like I said. So these things.
Okay, I'd like to start off by looking at the graph. I know I have to eventually involve area. So can we figure out where to shade, right? The shaded region is what's between the graph and the x-axis. You may see other shapes, but we only look at what's between the graph and the x-axis. So let's try that. Okay, so between the graph and the x-axis, we have this region. We have this region here, semicircle. We have the triangle here. Is that it?
The bottom.
Yeah. This is also between the graph and the x-axis. Okay, triangle, semicircle, triangle, triangle. Okay, h of 0. So we know that we're going to be involving the area, but also there's no definition. It's not saying h of x is the integral of f of x. All we're given is an f, which is really h prime, and we're giving a starting point. So we're going to use final equals initial plus displacement. We know that x would be initial plus displacement. So if I want to find h of 0, I have to start at h of -2 because that's the point that they give us. And then we got to figure out how much distance is between them. Between -2 and 0, this is going to be a quarter circle, or you can do a semicircle divided by 2. But this whole region is 1/2 pi r squared. So 1/2 pi radius. So I get 4/2, which is 2 pi. So we know this full semicircle is 2 pi, so I can split that 2 pi up. -2 to 0, that's going to be pi. So next up, h prime of 0. H prime is the f graph, right? So this is the h prime graph. H prime of 0 is the order pair. So up here at 1. Sorry, 2. H double prime of 0 is asking for the slope of this graph at 0. At 0, that's the hill of this graph, so it's the slope of 0. Okay, both decreasing and concave up at the same time. I like to create slope sine line and then concavity sine line and then line them up. So just as a reminder, this is the derivative graph of H. So above is positive slope, below is negative slope. On the x-axis, slope 0. -2 is the next intercept. 2 is the next intercept. And then 1, 2, 3. This looks like it's at 4.5. Looks like it's between 4 and 5 here. Okay, so we start off below the x-axis, which translates to be a negative slope. Between -2 and 2, all this is above the x-axis, so the original graph, positive slope. Between 2 and 4.5, also above the x-axis, positive slope. From 4.5 to 5, below the x-axis, negative slope. And then if we want to create a concavity sine line, we can do that by looking at the peaks and valleys, right? Any relative mins and relative maxes will be points of inflection. So I have one relative max at 0. I have a relative min at 2, and then relative max at 3. So 0, 2, 3. Now we look at the slope. Positive slope on the H prime graph means concave up. Still a positive slope, concave up. So concave up all the way here. Negative slope means concave down. Positive slope, concave up. Negative slope, concave down. Decreasing and concave up. So we want an arrow that's decreasing and at the same time concave down. Sorry, decreasing and concave up. That's it, right? That's the only place. You can also pull this from the graph as well. Decreasing and concave up means below the x-axis and the positive slope. So below the x-axis, positive slope, that's the only place that has it. Okay, next up, part C, j of x equals f of x times g of x over 2. Find the equation of the tangent line. So we have to find order pair and find slope and point slope form. So we can find order pair by plugging 4 into the function. And then we can find the derivative, then plug 4. Let's get the function here. So j of 4 equals f of 4 times g of 4 over 2. So f of 4, you can pull that from our graph here. F of 4 is 1. And then g of 2 pull that from our table. So we got the order pair out of the way. To get to the slope, we got to get to the derivative. To get to the derivative, hopefully you can see that there's a need for product rule. G of 2. G of 2, I'm just pulling it from the table here. Okay, let's go through product rule. Now G prime is outsize times insize derivative. So G becomes G prime of x over 2. What's the derivative of x over 2? 1/2. Another way to think of G of x over 2 is G of 1/2 x. And 1/2 x's derivative is just 1/2. If you don't want to look at a number below a variable, you can always push it out as a coefficient. Okay, so now it gets a lot easier. Replace all the x's with 4s. Get down to your slope value, and then put it all together, point slope form. Okay, any questions? First page?
This is. No, it's not. It's. It's just like that. And then you find some. And then comes. It says that. Each of the crimes equals that. So it's also each. Are we gonna have to do rules there on the test?
Rolle's theorem is same thing as mean value theorem, just do mean value theorem.
Oh, okay.
Okay, next page. Is there a time C such that G double prime is equal to 0? I mean, if we had a G double prime table, we could look to see if 0 shows up or if there's a number below or above 0, but we don't see that, so we need to rely on G prime. And we know that G double prime is the slope of G prime, so maybe if I can show that G prime slope is 0, then G double prime. But yeah, I guess in a way this would end up being potentially being Rolle's theorem, but we just look at the steps from mean value theorem and it'll take care of itself. So let's find the slope between the endpoints between -1 and 6. So we know that if we want to adapt mean value theorem or Rolle's theorem, we know that the slope of the G prime graph is equal to G double prime of C, which is adapting mean value theorem. So if the slope of the G prime graph is showing a value, then it must show up on the G double prime graph. So G prime of 6 minus G prime of -1 over 6 minus -1. So we go to our G prime table. G prime of 6, it's going to be 2. G prime of -1 is also 2. And then 6 plus 1 is 7. You get 0 over 7. How can I interpret that? That is 0, right? If you plug in the calculator, you'll get 0 as well. So if the slope between the 2 points on G prime graph is 0, there must be a place where the exact slope is going to be 0. So since G prime is continuous with brackets, differentiable with parentheses, and we show that the slope between the 2 endpoints is 0, there must be a point where G double prime is equal to 0. Okay, any questions with part D? Okay, next part E. Limits. First thing we do, direct substitution. We don't know exactly what's happening at 2, but direct substitution will tell us. Right? If we get a real number, then the limit exists. If we get a 10 over 0, 8 over 0, we know the limit does not exist. This is vertical asymptote. But if we get 0 over 0, that means there's a hole. The limit does exist. We just have to do a little bit more figuring out to get that value. But direct substitution first, 2 in for x. All right, so g of 2 is equal to 5. So we get e to the 5th minus e to the 5th over 2 minus 2. That does give us 0 over 0. So we do recognize that there's a hole, but the limit does exist. We just have to find it. We can go through L'Hopital's rule. So the rule for e to the u, derivative-wise, is e to the u times u prime. Minus, okay, what happens to e to the 5th? 0. Yeah. X goes to 1. Negative 2 goes to 0. So now that we have our derivative version, let's reevaluate our limit. So again, g of 2 is 5. So e to the 5th times g prime of 2, which is negative 2. And that is a real number. Negative 2 e to the 5th is my limit. Okay, part F, find the maximum value. So that should remind us of extreme value theorem. Remember, we want to test endpoints and critical points. But I can go back to my slope sine line and just pick out my candidates, right? I definitely have to test negative 7 and 5. And we can go back to part B and just look at our slope sine line. Don't look at your concavity sine line. This is not going to give you anything about max and mins. So negative 7 and 5. And then we see a relative minimum. This would be good if I'm trying to find absolute minimum, but I don't need to test negative 2. 2 is neither a max nor min. And then 4.5. Okay, 4.5 is a max, relative max, so I do need to include that point. So I have 3 points to test, negative 7 and 5 because of endpoints, and 4.5 because it's a critical point. But it's not wrong if you test it negative 2 and 2, we just don't have to. We know that these have no chance of being the absolute max on the graph. Okay, everybody good with identifying the appropriate candidates? Okay, so we're going to push them all through Final equals initial plus displacement, like how we did h of 0 at the beginning of part A. So if I want to find h of -7, I first have to start at h of -2 because that's my anchor point. Plus, and I'm trying to bridge the gap between -2 and -7. Now that I have my definition down, I realize that I'm going backwards here. I'm going from right to left. So I prefer to go from left to right. So okay, so something that I need to do with my graph, I'm just going to go ahead and start finding all the areas because I'm going to need them as I extend all the way out to the right of my graph here. So let me find all these values here. 1/2 base times height. Right below the x-axis. We found before that this was pi and pi. And this large triangle here, 1/2 base times height, my base is 1 to 2.5 or 5 halves. And then my height is 3. So I get 15/4 or 3.75.
Wait, how'd you get a base of 5/2?
Which is 2.5. 1 to 2.5.
So you did the whole, why didn't you split the triangle up?
I guess I didn't need to because I didn't have a critical point at 3. So I just figured I'm just going to go ahead and find the whole triangle. I mean, you could split it up if you wanted to.
Okay, because when I split it up, I got 3/2 and 3/4, and that adds up to be 2.25.
Let me see if we split it up. The first triangle will be 1/2 1 times 3, which is 3 halves. That's what you got, right?
Yeah.
And the other one will be
Why
1.
did the base be 1.5? Because it's 30. You know, it's up. Apple?
Let's see, 1.5.
Oh, I see. I did instead of 1/2, I did, or instead of 1.5, I did 1/2.
I see. Okay.
Okay.
But yeah, either way, we should be able to get to the same.
Yeah.
Value. Okay. Good.
Okay, I think.
Okay. Okay. Now this small triangle here is 1/2 1 times 1. So that's going to be just -1/2 down here. Okay. So triangle -5 halves, pi, pi, 3.75, and then -1/2 or -0.5. Okay, so h of -7 equals h of -2, which is 3, minus, and then we'll go from -7 to -2. So from -7 to -2, that's going to be -2.5. Two negatives makes positive, so I get 5.5. Any questions there? All right, next up, h of 4.5. Again, go through the same process, build off of your starting point, anchor point, plus the integral from -2 to 4.5. This one is already in order, so we don't have to flip the bounds. So from -2 to 4.5, that's just going to be pi plus the triangle. So h of -2 is 3. And then between -2 and 4.5, we have the semicircle plus the triangle. And that gave me 13.033. So, yeah. So, yeah, I started off starting at from -2 to -7 because that's what the definition gave me, and then I realized that I prefer to read from left to right. So then I changed the bounds, and then I balanced it out with a negative, and then from -2 to -7 to -2, it's just going to be this triangle below which is -2.5. And then the two negatives cancel it out, and I've got 3 plus 2.5.
And then for this one, would you say like by EBT, since h of x is continuous over the interval of -7 to 5, therefore there's an x value at it.
Yes, yes. I left out the continuous portion, but on the AP exam, they tend to, when they say justify your answer, they just want to see that you tested your candidates appropriately, and then you're making your conclusion from there. Yeah. And then from -2 to 5, we're adding up starting point, semicircle, triangle, and then we're also subtracting. Oh, sorry, I said -1/2. My bad. This triangle here is 1/2 base times height. The base is 1/2. The height is 1, so it's actually -1/4 or -0.25. Sorry, I said -1/2. That should be -0.25 for this small triangle here. And then when we compare all these values, we know the highest will be the absolute max. So the highest y value we see is that 13.033 or 6.75 plus 2 pi. Yeah, I'm not going to take any points off. Technically, that continuity is part of the condition, but on the AP exam, they don't have that in the scoring guidelines. So I think I'll just, if you just show your steps and tested the appropriate candidates and made the appropriate conclusion, that's good enough. Okay, anything before we get to part G? All right, we got a messy definite integral problem. We know we got to go through use substitution to get it so that we can figure out a rule that can work. So we do see a large set of parentheses or brackets here. That would be a good candidate for our U value. So we'll let our U value be G prime of 2x. And if we think if we look ahead, we know the derivative would be G double prime, and that should handle that leftover that we hope to cancel out. Yeah, so whenever we go through U substitution, we can always look at our U value and look to see, okay, is my derivative going to have a nice partner for it to cancel out and reduce? All right, so G prime of 2x, the rule for G prime of 2x is G double prime of 2x times what? Times 2, yeah, chain rule, right? I got it outside, inside, I got to involve both. Cross multiply. Make your substitution. G double prime, G double prime. We do have a leftover 1/2 that needs to come out. But after that, it should be a rule that we recognize. All right, integral U squared is U cubed. Keep the 1/2. U cubed over 3. I do want to evaluate the bounds, but I do want to bring back my original variable, which is G prime of 2x cubed. And now I can involve my bounds from -1 to 3. So G prime of 6, we can keep going because we actually have a table of values that we can make further substitutions. So G prime of 6 is 2. And G prime of -2 is -3. You can leave your answer like this, or you can keep going here. I get 8/6 plus 27/6, which is 35/6. But on the AP exam, this is also acceptable, leaving your answer. As long as everything is a numeric value, you can leave your answer and simplify it as well. Okay, let me know if you have any questions between 21 to 23 and this worksheet. Yeah, that's right. Because H prime, they tell us that H prime equals F. So we know H double prime must be F prime, which is making both kind of go down one derivative level. Yeah, H double prime. Right. So I choose the points. Remember, if I want to find points of inflection, I look at the max and mins of my H prime graph. It's a sharp point, but this is a positive slope, right?
I just
it's
left
followed
the
by-
last one over.
Right, so it needs to be a positive slope, negative slope, or a negative slope, positive slope, in order for it to be a maximum.
Yeah, it's good. And you have a walk. Yeah, I did see him. Yeah, yeah.
Because if I went all the way to zero, then it's gonna turn into an increase. One thing that's so they have no idea.
Nine? Did he add it? That's my bedtime. Wait, what do you mean? I'm not gonna be here during prepared for that at 10:30, so can I take the test during second period instead?
Sounds good.
Where's your backpack? I have a first year.
Yeah.
Would two be a point on the H double prime graph? I think some other, I think it's on the,
This one here?
yes.
Yes,
Okay.
I did include that on my H double prime, because it is a
It's
hill. 0 to 3.